Hi everyone. So today I am here with the complete discussion of JEE Advanced 2026 Physics Paper 1. Now we will be seeing all the important concepts which are applicable to these questions, and also I'll tell you about some questions which indeed are, if you can solve them, it's just like hitting the jackpot. And then why I'm saying that you can solve them, because these do not require any expertise. These questions are such, JEE people, they intentionally give such questions because these questions just check how smart you are. You have to simply rule out the incorrect options by looking at them, right? So we'll see all such stuff. Let's start with the discussion over here. So if you see the first question that they have asked, we have been given a static disk whose radius is capital R, and there are two smaller disks whose radius are small r each, and small r is given as capital R by 50. Now these two are made to roll with angular speeds omega and 2 omega without slipping, means pure rolling. Okay, so they are asking that when they will again come in contact, then what is the time taken, or how much time tau we have to calculate when the disk will come in contact. So how to solve this question? This question is actually an easy question, just based on relative motion and pure rolling. Let's see how. If you see, when they will again come in contact, obviously this particular gap, if you can see, this will be how much? This will be 4r, right? Now relative to each other, if you see, their centers will move, and their centers will trace this circle relative to each other to meet. Now if I take the radius of the circle traced by their centers, let's call it as r0. So what will be r0? R0 is simply capital R plus small r, which will become nothing but 51 r by 50, because capital R is small r is given as capital R by 50. So this will be the radius. Now relative to each other, if you see the speeds of centers, suppose I take this speed as v2 and this one speed as v1. Now what is pure rolling speed? V equals to omega r, so this will become 2 omega r. And what will be v1? V1 will become omega r. So relative to each other, the center of mass or centers of the discs, smaller discs, will have a speed v1 plus v2, because they are moving in opposite directions. So this becomes how much? 3 omega r, which we can also write as 3 omega capital R by 50, right? So now, as I said, the only thing that needs to be done over here is, in order to meet, let's see the relative distance travelled by the discs or their centers. So S relative can be written as V relative into tau. Now what is S relative? S relatives, you can see that this circular part whose radius is r0, but the complete circle we have not to take. We have to eliminate or remove basically 4r from the complete circle length. So that will be the relative distance travelled. So what we will write that as? Nothing but 2 pi r0 minus 4r. This will be the distance travelled relative to each other by the centers. V relative is, we got 3 omega r upon 50 and into tau. Now just substitute the values. What is r0? So we can put 2 pi 51r upon 50 minus 4, small r can be written as capital R by 50, and here we have 3 omega r tau by 50. So we can remove capital R by 50 from all, and from here if you take 2 pi common, because in all the options, 51 is taken common, 51 is taken common. So if I take 51 common, then let's see what will be coming. 50 all are gone, r is gone. So first you will have 2 pi minus, in the next term you have 4 divided by 51, and since here we had 3 omega multiplied with tau, so that 3 omega will get divided. So 51 by 3 omega 2 pi minus 4 by 51. If you see the option, which one is it? Yes, it is option C. So this will be the correct option. I hope this question is clear to you. Okay. Okay, so in the second question, we have a circuit, an outer circuit and an inner circuit. So in the outer circuit you can see that there is a capacitor, there is an AC source and there is a coil whose number of turns per unit length is given as capital N, the area of cross section is given as capital S and the length is given as small d. Whereas there is a coil inside also whose area is S by 2, number of turns per unit length is 2N and the length is D by 2. Now the inner coil has been short circuited. So the outer and inner coils are obviously mutually coupled over here. So they are asking that if we neglect the edge effects and all the ohmic resistances, what will be the resonant frequency of the circuit? So they are asking about the resonant frequency of the outer circuit. So how to solve such questions? Well, you can see that a coil, since this coil is connected to a circuit which is having time varying voltage source, so obviously we can say that there will be inductance, self-inductance, and also since it is coupled with the inner coil, so there will be mutual induction as well. Now when we have two circuits, so at any particular instant, suppose I assume that the outer coil, let's take its self-inductance as L1 and the inner one's self-inductance, let's take it as L2. The outer one suppose carries a current I1 at a particular instant and the charge is Q and let's take the source voltage as V. Inner one, let's take at any instant the current as I2. Okay. So if we write the EMF equations at any instant, so first we can write for the outer circuit, so for outer circuit what will be the equation? We can write the applied voltage, AC voltage V. This will be the capacitor voltage at the instant Q by C plus, due to self-induction, what will be the value? It will be L di1 by dt, the rate of change of its own current for the outer coil, and there will be mutual induction as well. So M, since the inner I have assumed to carry current I2, so I will take M di2 by dt. So this is the expression. Now from here we have to find the resonant frequency. We know that resonant frequency is 1 by root LC, but here you can see that here L, M, Q, everything is coming. So it is not presently obtainable from this particular equation. Moreover, we have di1 by dt, di2 by dt, lot of unknowns you can see. But let's see what other important thing we have over here. If you see the inner circuit, well, the inner circuit is short circuited. There is no AC applied source. So here for inner circuit you have self induction, so L2 di2 by dt due to self induction at any instant if the current is I2, plus due to mutual induction we can write M di1 by dt. Now since it is short circuited we can write it as 0. So first and foremost what we can do, in the first equation, if I want to remove this I2 term, we can remove it from here. So what I can write from here is di2 by dt. This can be replaced by minus M by L2 into di1 by dt. Got it? Now let's quickly write the values of M and all so that we get an idea what to do next. Achha, here it was L1, I missed that thing, L1, and here we have L2. So if I write the values, what is L1? We know self-inductance formula, everyone should be knowing these two basic things. Self-inductance is given as mu naught number of turns per unit length square into volume, whereas mutual induction between the coils is mu naught N1 N2 into volume of the smaller coil. So these are the expressions. So if you use that, what we can say from here is L1 will become mu naught number of turns for outer one is given as capital N, N square. Volume will be what? S into D. Okay. So what we can do, let's call this as L. So they have said the self-inductance of the larger coil is L, right? Now what is L2? L2 is mu naught number of turns per unit length is given for the inner one as 2n into volume. Volume will become S by 2, length is D by 2. So from here you can see 4 and 4 will cancel. It has the same expression as L1. So it will also become equal to L1, which is nothing but L. Now if you see mutual inductance, what is mutual inductance? Mu naught N1 N2. N1 N2 will become how much? 2n square into volume of the smaller coil. Volume of the smaller coil is how much? Sd by 4. So from here you can see it is nothing but half of L, that is L by 2. So from here if I substitute M by L2, so M by L2 will become nothing but 1 by 2. So it becomes minus half di1 by dt. So if I write the equation again and I substitute the value di2 by dt as minus half di1 by dt, and we know already the value, so what we are going to get, let's quickly write the expression. So if I put in equation number 1, we got V is equals to Q by C plus L1. L1 was L di1 by dt. Next term we got M. Now what was M? M value we got as L by 2. And then we had di2 by dt, whose value we just saw. The value became how much? Minus 1 by 2 di1 by dt. Got it? So once we get it, so we can simplify it a bit and we can write it as Q by C. Now you see it will become L minus L by 4. L minus L by 4, which is 3L by 4 di1 by dt. Got it? Now you can see we can express it as a differential equation, and that's all. So we can write L equivalent. What is I1? I1 is nothing but the rate of change of charge, flow of charge. So rate of flow of charge, so dq by dt. So I1 being dq by dt, so this will become d square q upon dt square plus q by c is equals to v. So when we have a differential equation of this form, then this C and this L equivalent, from here only we get the resonant frequency. Omega naught is nothing but 1 by root LC. So here we will simply use this. So L equivalent is how much? 3L by 4. So when we substitute 3L by 4, this 4 under root 2 goes up, and below we are left with root 3 LC. So 2 by root 3 LC. Let's check any option. 2 by root 3 LC. Yes, we can see. So this is which option? Again, option C. I hope this question is clear to all of you. Okay, so here is question number 3, in which a solid cylinder of radius capital R is said to roll without slipping on a horizontal surface, and there is a vertical edge So the initial speed of center of mass is given as root gr by 3, and when it reaches the edge, what happens? Due to rotation, it will lose contact. It will lose contact with the surface. So the moment it loses contact, they are asking what is the speed of the center of mass. So first thing is that since it is rolling purely, so we can go by energy conservation. And since the cylinder turns, so the center of mass will obviously come down from its initial level, and hence there will be loss in potential energy, gravitational potential energy, and there will be gain in the total kinetic energy associated with rotation or rolling. Rolling. So we can conserve the energy, and since the cylinder is turning at the edge, so what will happen that at that time the center of mass will be turning in a circular path about the edge. So let's see how to solve this particular question. I have already drawn a neat diagram for the same. Now here what is happening is, initially the center of mass we can take at this height, which is capital R, above the surface. Now the speed of center of mass is already given in the question as root gr by 3. It will have angular speed also, omega naught, which we can write omega naught will be v naught by r, right? Now when it reaches at this point, let's take the edge as A. So center of mass now comes to this position. You can see it has descended by a certain height h. How to find h? Simple. Suppose this line ACM has turned with respect to vertical by an angle theta. Now you can see that this length will be what? This length is r. So this height is how much? By trigonometry r cos theta. So how much is the height descended by center of mass? Capital R minus r cos theta, which we can simply write h is equals to r into 1 minus cos theta. Now at that instant, let's take the speed of center of mass as v, which we have to find. And obviously there will be an angular speed omega, which will again be v by r. Fine. Here if we see the total kinetic energy, we know for a rolling body the total kinetic energy is half m vcm square 1 plus k square by r square, where k is the radius of gyration. For a solid cylinder, k square will be how much? R square by 2. So for solid cylinder, k square upon r square will be how much? It will become 1 by 2. So if this becomes 1 by 2, that means the total kinetic energy at any instant while the cylinder rolls will be 1 plus 1 by 2 is 3 by 2. There is one more 2, so it becomes 3 by 4 m v cm squared. Now you can see from here to here, from this instant to this instant, there is loss in gravitational potential energy, and that is equal to gain in total kinetic energy. So when we use this, what we can say, the loss in potential energy is mg h. H is what? R into 1 minus cos theta. Gain in kinetic energy expression we got 3 by 4 m. VCM final I have taken as V, so V square minus VCM initial, which is V naught square. Got it? So we already have the value V naught as root gr by 3. Everything is known, we have to find V, but we are stuck with this cos theta. How to get it removed? For that we can see this particular diagram over here, which I have drawn separately. Here center of mass, as I said, is turning along a circular path whose radius is capital R, and it has turned by an angle theta where contact is lost about the point A. So here normal reaction is 0. But center of mass moving in a circle about the point A, so there should be a force which will be providing its centripetal acceleration. Which force is left? The only external force acting at this instant will be mg. Normal reaction becomes 0. So you can see that there is a component. If this angle is theta, this will be theta. This angle will be also theta. So you can see there is a component of mg acting radially inwards, which is what? Mg cos theta. So mg cos theta provides centripetal force. So it will become equals to mv squared upon r. So we can substitute v square in place of rg cos theta. So v square can be substituted in place of rg cos theta. Cos theta was unknown. So coming back over here, first of all you can see that m got cancelled. We can multiply 4 this side. So 4gr, right? Minus, again 4 comes. You can see here gr cos theta. Gr cos theta as it is v square, so we have v square. This side we have how much? 3v square. Minus 3 v naught square. What is v naught square? V naught square is gr by 3. So from here we can take like terms on one side. So here 3 cancels. 4gr plus gr, 5gr comes on one side, and here we have 4v square plus 3v square. 4v square plus 3v square is equals to 7v square. 7v square. So from here what we can say is v will become equals to what? From here v will become equal to root under 5gr by 7. So the center of mass speed will be root 5gr by 7. Is there any option here? Root 5gr by 7. Yes, we have the second option as the correct one. I hope this question is clear to all of you. Root 5gr by 7 will be the speed. So let's now move towards or move to the next question. Let's move to question number 4, in which they have given a double convex lens made of glass of refractive index 1.5. Radius of curvature of the curved surfaces are given 20 cm each. Now this lens is immersed in a liquid whose refractive index is given as NL. They are asking the correct plot showing the variation of power which is taken in diopters as a function of NL. Now here the question setter, they did not he did not mention properly that whether the power being asked is just the optical power or with respect to the medium or the liquid in which the lens has been placed. So there are two possible correct answers for this question, and finally in the answer key also they had given both the correct options. Let me explain how we find this. So first of all, what we do, we know the expression for focal length when we write. So 1 by focal length of lens with respect to medium, we go by mu of lens by mu of medium minus 1 into 1 by R1 minus 1 by R2. This is what we write if we are taking in centimeters. Now R1 is given as 20 centimeter, we know for convex lens positive, R2 will be negative, so minus 20 centimeter. Mu L is mentioned made of glass 1.5 and this is given as NL. So from here we can write 1 by focal length of the lens in medium. This expression we are taking focal length in centimeter. So what we are getting from here, if you see, we have 1.5 by NL minus 1 into 1 by 20 plus 1 by 20 becomes 1 by 10. Clear? So this is the expression that we have. Now next thing, if we just write the power of the lens. So power in diopters, just if power is asked, so 100 by focal length of lens in medium, if you take the focal length in centimeter. So to write power in diopters, we write like this. So we simply need to multiply this expression by 100. So when you will multiply by 100, so 100 by 10 becomes 10. we have 1.5 by NL minus 1. So if you break this, you will get 15 by NL minus 10. So if you arrange the terms on one side, we can see P plus 10, then multiply NL. This will become equals to 15. Now if you see P plus 10 into NL is 15, if you take this as capital Y and this as capital X, so XY is constant, so this means we have P versus NL graph will be a rectangular hyperbola. So this will be a rectangular hyperbola, and what will be the asymptote? What will be the asymptote here? So the asymptote will be P equals to minus 10, because if you take P equals to minus 10, then NL will become how much? 15 by 0, that is infinite, right? So here we can see a rectangular hyperbola, and if you take the value of NL, the least value of NL possible is how much? 1, which is vacuum or air. So if you will put over here, if NL the least value is 1, so from here power will become P plus 10 is 15, so power will become 5 diopters, right? And if you take P equals to minus 10, then NL will become infinite. So as NL is keeping on increasing, if P equals to minus 10 diopters, so NL will become infinite. That means this is the asymptote. So this is the asymptote of the rectangular hyperbola. So which one we can see is the correct choice? And if you take power as 0, that also we can check. If you take power as 0 diopter, then we have NL will become 15 by 10. 15 by 10 is 1.5. So NL becomes 1.5. So yes, we have a rectangular hyperbola satisfying these conditions in the options given. Which one? Option A. You can see this rectangular hyperbola, and this will have an asymptote at P is minus 10. So when P will become minus 10, it will be the asymptote. So this is one option. Now this was the power, just the optical power. But if I write the power with respect to the medium, then things will change. In which way will it change? Now we know the value of 1 by FL over here. We are seeing this expression. Now I'll show you what will happen next. With respect to the medium or liquid, we define the power as refractive index of the medium in which the lens is kept divided by the focal length of lens with respect to medium. And if you are taking in diopter, so and if you are taking this in centimeter, you have to multiply by 100. That is the for sure, but only extra term that gets multiplied is mu medium. So when you take this, this will become how much? NL. Now apart from this 100 by FL, you saw previously 100 by FL, this value we have already found, 15 by NL minus 10, right? So 15 by NL minus 10. So if you break the bracket, you will get the first term as 15, NL cancels, minus 10 NL. Now if you see, if you take P on y axis and NL on x axis, so this is what? It is a straight line. So P versus NL graph is a straight line. And how will the straight line look? Simply, if the least value of NL, which we know is 1, so from here P will become 15 diopters minus 10 diopters, which is 5 diopter, and P will become 0, then NL will become 1.5. So we have a decreasing straight line graph P versus NL. So you can see when NL is 1, then P is 5, and when NL is 1.5, P becomes 0. So another possible graph is this one. Do we have this? See, yes, we have the option B. So as I said earlier, both option A and B will be the correct one for this particular question. I hope this is clear to all of you. So we'll move towards the next question. Okay, so let's see the discussion of question number 5. So here we have hydrogen atom with Vk, Rk and Kk denoting the velocity, orbital radius and kinetic energy of the electron in the kth orbit. Now this electron is said to undergo a transition from the nth orbit, emitting radiation corresponding to the Lyman series. Lyman series means it will jump to quantum number 1, n equals to 1, from n equals to n. So Planck's constant, permittivity of free space, these are given. They have asked to find the magnitude of change in kinetic energy, de Broglie wavelength and so on. Now this question is a bit tricky, and the tricky part is that you have to get hold of the proper expressions because you have to match with the options given, right? So let's proceed with the solution of this question. First of all, talking about the change in kinetic energy. Now we know kinetic energy in the nth orbit, if I write as Kn, this is half m Vn square. But they have not mentioned the mass in the option A. That means we have to remove mass. So what we can do, we can make a change. We can write mv square like this. By doing so, we know that angular momentum quantization gives us mvn Rn is nh by 2 pi. So we can substitute and hence remove mvn as nh by 2 pi Rn. So if I put in the expression of kinetic energy, so Kn becomes simply nh Vn by 2 pi Rn. So they are asking the change in kinetic energy over here, which they are taking as Ken minus Ke1. So we can write as h by, I'm sorry, h by 4 pi n Vn by Rn minus V1 by R1. So from here we can see the option A, which they asked us to check, h by 4 pi n Vn by Rn minus V1 by R1. This is same given. So yes, option A is correct. Now let's see the next one, which is about de Broglie wavelength. Now de Broglie wavelength, which is given by lambda is equals to h by p, p being the momentum. So by Bohr's quantization we also know de Broglie wavelength is related to the orbital radius as n lambda is 2 pi Rn. So from here the de Broglie wavelength lambda n can be expressed as 2 pi Rn upon n. Now here in the expression of de Broglie wavelength you can see that kinetic energy is required and E square is given. So we have to replace 2 pi Rn. Now students, what they will think that 2 pi Rn I can remove from here also, I can write 2 pi Rn in terms of kinetic energy. But that will not be correct, because you will get 2 pi Rn in terms of kinetic energy, but there is Vn also. And here you can see that there is no mention of Vn in the option. So what we will do in such case, we can use this concept that the electrostatic force exerted by the nucleus on the electron provides it the centripetal force. So in nth orbit, the electrostatic force will become Q1 Q2, that is E square by 4 pi epsilon naught Rn square. This is the electrostatic force. This provides the centripetal force to the electron. So mv square by R. We can write like this, right? But we know mv square is twice of the kinetic energy of the electron. So we can write it as 2kn in the nth orbit by Rn. So from here 1 Rn will cancel, and we can take 2 is already here and pi Rn on the other side. So from here we can write 2 pi Rn can be expressed as E square, and 4 is left, kinetic energy will come down, and epsilon naught. 4 epsilon naught kinetic energy. This is the expression. But 2 pi Rn is equals to n lambda n. So from here we can substitute lambda n as E square by 4 epsilon naught n kn. Got it? This is the expression for lambda n. Now we are in need of the change, magnitude of change. So if we go by the B part, lambda n minus lambda 1. So what will be common here? This will become E square by 4 epsilon naught common, and we have 1 by n kn minus 1 by k1. But if you see in option B, E square by 4 epsilon naught is correctly given, 1 by kn is given, whereas we have 1 by n kn. That means this is not correct. B is wrong. Before moving to C, we can directly see D option, because that will be much easier. Why so? You will understand. If you see D option, magnitude of change in total energy of the electron. Now we know that since energy of electron, total energy of electron is negative of kinetic energy of the electron, so that means the change in energy will be same as change in kinetic energy. Magnitude wise both will be same. The change in kinetic energy magnitude we had already seen, which is given in option 1. So same option A, I am sorry, which will be h by 4 pi nvn by Rn minus V1 by R1. But if you see, they have given here h by 2 pi, so this is wrong. So that means D option is wrong. So we checked 3 options over here. D option is wrong, B option is wrong, A is correct. Now remains frequency of the radiation emitted. For frequency of the radiation, what we can use, you can see the expression of frequency given, E square h R1 Rn, and these values are given. Okay. So for frequency we have an important concept. So we know energy of the photon, if you go for the C part, energy of the photon is h into frequency of the photon, and this is simply the difference of energy of the participating orbit. So En minus E1. Now En minus E1 can be written as K1 minus Kn. This is what we can write, because En is minus of K. So from here En minus E1 is K1 minus Kn. Okay. So from here we can see Fp can be written as 1 by H K1 minus Kn. Now since they are asking the expression in terms of R and E square, which we just saw here, can you check from here? We can use this expression. Kinetic energy can be written over here as Kn can be written as E square by 4 2s are 8 pi Rn. Can you see? Kn can be written as E square by 8 pi epsilon naught Rn. So here I can take 1 by H common. K1, if I want to write K1, it will become E square by 8 pi epsilon naught. Rn will become R1. And similarly, for Kn, it will become E square by 8 pi epsilon naught Rn. So the final expression, taking the terms common, E square by 8 pi epsilon naught H 1 by R1 minus 1 by Rn. So E square by 8 pi epsilon naught H 1 by R1 minus 1 by Rn, that means we can say that yes, C option is also correct. So the correct options for this particular question, if you see, are option A, option C, and the incorrect ones are B and D. Clear? Let's move on to the next question. Okay, so let's proceed with question number 6. In this, a particle is thrown with speed v, angle theta. They have given a point P which is 1 meter above the ground and 5 meter away from the point of projection. So they are asking that if this particle passes through the point P, then which of the options are correct. So first of all, what we will do before solving the question, let's draw a straight line the particle would have followed if it was thrown along this line and there would be no gravity or uniform motion would be there, it would directly hit P. But because of gravity, it will follow a parabolic path and it will hit at P while going up or coming down. That we have to check, right? So here what I am saying is, if I take this angle say as alpha, so first of all let's find this value tan alpha. I can write it as 1 by 5. Now why I am writing this, you will understand it soon. Next, if we are asked in option A that theta is given as 45 degree, what will be the value of the speed of projection? So since we know the height and distance, so taking horizontal as x-axis and vertical as y-axis, we can directly go by equation of trajectory. Y equals to x tan theta minus gx squared upon 2 v square cos square theta. So from here, if I put the value of y as 1, x as 5, tan theta will become 1, g as it is, 5 squared will become 25, and 2 v squared cos square 45 will be 1 by 2. So 2 cancels. So from here, v square will become 25g by 4. So you can see here v square will become 25g by 4 because 5 minus 1 will come 4. So v will become 5 root g by 2 meter per second. Means A option we can see is correct. It's correct. Now next thing, they are saying that at 45 degree and 30 degree angle, the particle will reach the point P before reaching the maximum height or after reaching the maximum height? We have to check that. So for that only I had drawn this. So understand first of all that when you are taking V as 5g root g by 2, the maximum possible range, if you see the maximum possible range for this projectile, R max, what will be R max? We know R max is at 45 degree, which is V square by g. So when you will take V square by g, it will become 25 gg cancels by 4 meter. So when you find R max by 2, why I am finding R max by 2, you will understand it, 25 by 8 meter, because maximum height occurs for half of range. So R max is 25 by 8, which is 3 point something, which will be less than 5 meter. That means this 5 meter is more than half of the maximum range. That means this projectile, if it passes through P, obviously it will be passing after reaching the maximum height, where you can see theta is greater than alpha. So tan theta will become greater than tan alpha. So this case will occur. So it will attain the maximum height earlier. This is the maximum height, you can see, will be attained earlier. So P point will be attained after maximum height whenever theta is greater than alpha. So if you see in B and C part, now first of all, tan 45 is 1, tan 30 degree is 1 by root 3. Both these values are greater than 1 by 5. Means theta, either you take 45 degree or 30 degree, is greater than alpha. So if it is greater than alpha, that means H max will be attained earlier before reaching P. So H max is attained earlier before reaching P. So theta is 45 degree, particle reaches its H max before it reaches P, correct? For 30 degree also, maximum height will be reached earlier, but they are saying in C option, 30 degree particle reaches its maximum height after reaching point P. So this is wrong. Now comes the last part. What is that? The part D. If tan theta becomes 1 by 5, they have said theta is tan inverse 1 by 5. So tan theta is 1 by 5, which is tan alpha. So this means theta is equals to alpha. So if theta is equals to alpha, so just say what will happen. If theta becomes equals to alpha, then obviously the projectile will curve down below this line. So if it will curve down below this line, can it ever hit P? Answer is no. So they are saying that if theta is equals to tan inverse 1 by 5, then V is 125 root g meter per second. So this indeed is a wrong option. That means if theta becomes equals to alpha, it can never reach the point P. So which all are correct options? A and B. I hope it is clear. So let's move on to the next question. Okay, in next question, we have been given a quasi-static cycle of a monoatomic ideal gas, isothermal process AB, then followed by isochoric process, and then C2A, they have given an adiabatic process. The volumes of the gases are denoted as V1 and V2, and input and output heat they have given. Efficiency is defined as Q in and Q out by Q in. So we know that Q in, Q out, these are the magnitudes of heat. Then only you can define efficiency in this way. So they are asking which of the given options are correct. So let's see one by one what is happening over here and what all we have to take as assumptions and all. First of all, AB is an isothermal process. Temperature is constant. So in this, temperature during AB, let's take it as my wish T0. I have assumed it as T0. A, B, every point has that only. Okay. So first of all, if we write delta QAB. So it is isothermal expansion, so obviously heat will be positive. So delta QAB will become N R T naught log final volume by initial volume, which is Vp by Va. So we can write it as nRT naught natural log Vb is V2 by V1. So this is positive. Clear? Next, delta QBC. So delta QBC, now you can see it is isochoric and the pressure is decreasing, so temperature will also decrease. So delta QBC will become equals to delta UBC, which is NR TC minus TV. So we can write this as NR TC minus, we are writing delta UB, not the work done. So delta UBC will be NCV TC minus TB. So since it is given a monoatomic gas, so we can write it as 3R by 2 value of CV. So 3 NR by 2 TC minus T naught. This is the expression. Now we know that in B2C volume is decreasing, so temperature will also decrease, so this heat will come as negative. So it is released heat. Then delta Q CA, since it is adiabatic process, it is 0. So first of all we got out of these three, Q in was the supplied heat, which is the magnitude. So obviously it is positive, so delta QAB is only Q in. So this value became how much? NR T naught natural log V2 by V1. Fine. And Q out is the magnitude. Q out is the magnitude of rejected heat. So rejected heat was in BC. So we have to take its magnitude. So when you will take the magnitude, obviously this is negative, so you have to write it in the positive way. So 3 NR by 2 T naught minus TC. This comes out as Q out. Now once we got Q in, once we got Q out, then when we are being asked to calculate the efficiency, so first of all we have to see V2 by V1 is given as 8, then heat released in the process BC is smaller than heat absorbed in process AB. Let's start with option A first. If you see, it is a clockwise cycle. So delta Q cyclic, obviously it is clockwise PV cyclic process. So delta Q cyclic will become equals to delta QAB plus delta Q BC plus CA is 0 only. Since it is clockwise cyclic process, we know clockwise cyclic process delta Q is equals to work done, and work done in clockwise cyclic PV diagram is positive. Fine. Now we know that delta QBC is negative. Delta QBC is negative. So we can write this as, it is already positive, QAB is positive. This is negative. So I can write it as minus of magnitude of BC. Fine. This is greater than 0. So this clearly tells that delta QAB is greater than the magnitude of delta QBC. Means more heat is absorbed in the process AB compared to the heat rejected in the part BC. So for any value V2 by V1 8, it doesn't matter. We are seeing that yes, BC process heat is smaller. So that means we can say from here that option A is correct. Okay, option A is correct. Next, for a given value of V2 by V1, eta does not depend on the temperature of the isothermal process. Now they are asking about efficiency for a given value of V2 by V1. So how can we write efficiency now? Now efficiency is Q in minus Q out by Q in. So you can write it as 1 minus Q out by Q in. Now if you divide Q out by Q in, Q out by Q in, you can see NR cancels. So you will get 1 minus, here we have 3 T naught minus Tc divided by 2 T naught natural log V2 by V1. Okay, so they are saying that for a given value of V2 by V1, V2 by V1 is known to us, then efficiency won't depend on the temperature of the isothermal process, that is, it will become independent of T naught. We have to prove that, right? So how can we prove that? Well, it can be done in this particular way, that if you see the process C2A, it is which process? C2A is adiabatic. So if I go in the process C2A, adiabatic process, we know Tv to the power gamma minus 1 is constant. So Tc, volume is V2, gamma minus 1. So gamma minus 1 will become equals to Ta is T naught, V1, gamma minus 1. So in place of T naught, I can substitute Tc V2 by V1. For monoatomic gas, gamma is 5 by 3, 5 by 3 minus 1 is 2 by 3. So if you substitute it over here, so efficiency you can see becomes 1 minus 3 by 2. Tc you can take common, and we have 1 minus V2 by V1 power 2 by 3, and in denominator also T naught value you can substitute in terms of Tc. So Tc V2 by V1 power 2 by 3 and natural log V2 by V1. So you can see from here that there is no term of T naught. So T naught has been completely removed. It is depending only on V2 by V1. So for a given value of V2 by V1, efficiency does not depend on the temperature of the isothermal process. This statement is also correct. So both the statements we got here correct. Now let's see the other two remaining statements. What can we say about them, whether they are correct or not. So the C part being given, if V2 by V1 is 8, temperature of gas at A is 4 times the temperature of gas at C. Okay. Now coming to the part C of the question. They are saying V2 by V1 is 8 and temperature of gas at A means T naught, how much times it will be that of C? Well, we can see from this particular case only. So TA, which is T naught, we saw is equals to Tc V2 by V1 to the power 2 by 3. Now they have given V2 by V1 is 8. So Ta becomes Tc 8 power 2 by 3. Now 8 power 1 by 3 is how much? 2. 2 to the power 2 is how much? 4. So it becomes 4 Tc. So Ta is equals to 4 Tc. Yes, it is also a correct statement. Temperature of gas A is 4 times. Correct. Now comes the last part of the question. V2 by V1 is 8, then the pressure of gas at A is 4 times the pressure of gas at B. Now A to B you can see isothermal process. So for D part, when we go from A to B isothermal process, we can directly use PV is constant. So PA, VA is V1, PB, V2. Now PA will be PB into V2 by V1. They have given V2 by V1 is 8. So V2 by V1 is 8. So 8 times PB. So pressure of gas at A is 8 times the pressure of gas at B, not 4 times. So this one is wrong. So option A, B and C are the correct ones for this question. I hope this is clear to all of you. So let's proceed with the next question now. Okay, so let's see question number 8. The electric field associated with an electromagnetic wave traveling in vacuum is given. It is along I cap, means in question they have mentioned that E vector is along x-axis. Fine. Now the direction of propagation of wave, we know whenever we have an expression written, for example if it was written as kx plus omega t, so we say that the wave is moving along negative x direction. If it is ky plus omega t, we will say the wave is moving along negative y direction. But here we have seen terms 3y plus 4z plus omega t. So what we can say over here, that when you have this expression 3y plus 4z plus omega t, this is given as the phase angle. So this denotes the wave vector component along y direction. This one will denote the wave vector component along z direction. So when they are saying the magnitude of the wave vector, so first of all we can say the wave vector k is under root of ky square plus kz square. So 9 plus 16, 25, root 25 will become 5. So it will become 5 from here. Now next thing, we are getting this as 5 meter inverse. They have given the magnitude of wave vector as 0.5. So this is wrong. B is wrong. Now wave is traveling in which direction? So as I was just telling that if you have wave traveling along x-axis, positive x-axis, then it will be kx minus omega t or omega t minus kx. But since here both the terms are positive, that means the wave is moving along the opposite, exactly opposite to the direction 3y plus 4z. So here we can say that wave propagates along minus r cap direction. Now you will say what is minus r cap? Again telling why I am taking minus, because as I said that if just it was kx plus omega t, so you will say that it is moving along negative x-axis. Similarly, I am taking the wave propagating along negative r cap, where r cap is, just see the vector terms, with y you have 3, with z you have 4, so it is 3j cap plus 4k cap. Since it is unit vector, so we have to take the magnitude, so divide by 5. So the wave will propagate along minus r cap, that is minus of 3j plus 4k by 5. So you can see from here, yes, it is correct. So minus 1 by 5 if you take common, 3i plus 4k, that is what 3j plus 4k, that is what we are getting over here. So option A is correct. Now comes part C. What is the part C telling? They are asking omega. So we know that V is equals to omega by k. Now since they have said that the electromagnetic wave is traveling in vacuum, so it will become C. So from here omega will become C value we know 3 into 10 to the power 8 and K value we found as 5. So 3 5s are 15 into 10 to the power 8 radian per second, or if you write it as 1.5, so you can write 10 to the power 9 radian per second. So if you check the option, yes, option C is correct. Now comes the last option, which is option D. They are asking that the magnetic field associated will be in this direction or not. Yes, if you say magnetic field, if you go by this, what they have mentioned, if suppose B is correct, this one, which they have written E naught by C sine 3y plus 4z plus omega t, and they have attached 4i cap minus 3k cap. So if you want to find the peak value B max, so what will be the peak value? Sine peak value is 1, so you will get E naught by C. This value is 1, and this one magnitude 4i minus 3k magnitude will become under root of 4 square plus 3 square, that is 5. B max is E naught by C into 5. But we know B max actually is nothing but E naught by C for electromagnetic wave propagating in vacuum. So we are getting E naught by C into 5, but actually it is E naught by C. So this is not possible. So that means this option is also wrong. I hope this is clear to all of you. Okay, let's check question number 9. So here we have a tank which has two immiscible liquids of L by 2 being the height of the lower one, and there is a rod whose length is L, and it is fully immersed so that L by 2 length is in the lower liquid. Now the lower liquid, they have mentioned the lower liquid has density 6 rho and the upper one has density 2 rho. The rod's density is mentioned here as rho. So they are saying that if the rod is slightly tilted and released, so it will perform small oscillations. When this is slightly means small angle theta, and so obviously we have to take some approximations. So they are saying the time period of small oscillations is 2 pi by n under root L by G, so what? With a value of n. So let's proceed with the solution of this question, and for this also I have drawn a diagram to save some time earlier. So if you see here what they have mentioned, if we go by that, this length is L by 2. Fine. So if I mark a few points over here, if I take say this point as P, this end of the rod if I take as Q, this is R. So PR, now since the angle is very small, so some approximations that we can go on with, tan theta, sin theta, approximately we will take theta in radians, cos theta will be approximately 1. So we can say PR will be approximately L by 2 only, and same goes with RQ. Now I have marked here the weight will act at the center of gravity. So center of gravity is very close to this point. So here this distance we can see PCG, which is actually L by 2. So this is very near to the point R. Now center of buoyancy will be at the midpoint of the total length of the rod immersed in the liquid. So we can say that center of buoyancy, since this length is L by 2, PR is also approximately equal, PR is approximately equals to L by 2. So this PCB1, this gap or this gap, this approximately will be L by 4. So half, so we can take this also, PCB1 approximately equals to L by 4. And same applies to RCB2. This is L by 2, so this will be also approximately L by 4. Okay. So once we know this, and PCG, as I said, this one, this will be L by 2 only. So when we have such approximations for small angle, now if you see, the moment we turn it clockwise by theta and release it, so the restoring torque will be anti-clockwise. So if I write the restoring torque about the point P, so I can see that B1 and B2, their torque will try to restore it, whereas the torque due to W will try to bring it back. So now we have to multiply the forces with the perpendicular distances. So for, you can see, for B1, this will be the perpendicular distance from point P. For weight, we need to see this one. So in this particular way, if I, for B1, this will be the distance. This is L by 4, so this distance will become L theta by 4. For weight, this is L by 2, so this will become L by 2 into theta, approximately, small angles. And similarly, for CB2, this total length will become L by 2 plus L by 4. So from here, approximately, we can take it as L by 2 plus L by 4 into theta. Clear? Now, the restoring torque, as I said, B1 into L theta by 4 plus B2. B2's total distance is L by 4 plus L by 2, which will become how much? 3L by 4 theta. And the torque due to weight of the rod, so W into L theta by 2. Now if we are able to express it directly proportional to theta, so we get torque is equals to C theta, where C is called as the torque constant. So from there we can find the time period of SHM. Let's see. Here, what is B1, B2 and all, if we substitute, we will get B1. B1 is volume inside the first liquid, volume of the rod inside the first liquid, which is how much? Volume of the rod inside the first liquid is area of cross section of the rod is suppose A. Length in the first liquid is L by 2. This is volume. Into density of the lower liquid, which is given in the question as 6 rho. We already saw, into G. If you see B2, buoyant force exerted by second liquid. So for this volume inside, we have A L by 2. But if you see in the question, this liquid had density 2 rho. Upper liquid has density 2 rho. So 2 rho into G. And if you see weight is total volume A into length of the rod L, density of the rod rho into G. So when we substitute the restoring torque about the point P, what we are getting, let's see, here we have 6 by 2 is 3 A L rho G, there is one more L square, divided by 4 we have. Clear? Theta we can take common outside, plus B2 into 3L by 4. So 3 by 4 into B2. So first of all you can see here 2 cancel. So 3 by 4 AL square rho G. This is what we get. Minus weight into L by 2. So we will get AL square rho G by 2. So this into theta. 3 by 4 plus 3 by 4 becomes how much? 3 by 2. 3 by 2 minus 1 by 2 is 2 by 2. Means you get it as AL square rho G into theta. So this becomes our torque constant C. So once we get the torque constant C as AL square rho G, so we know it is case of SHM, angular SHM. So AL square rho G, if we substitute in the expression for time period, so time period will be given as 2 pi under root moment of inertia about the point about which it is rotating, which is the point P, divided by the torque constant C. Now since it is the end axis of the rod, so IP can be written as ml square by 3, and we got this as AL square rho G. Clear? Now what is obtained from here? Mass of the rod we can write as AL into rho. So time period expression hence becomes 2 pi under root AL into L square L cube rho by, we have got 3 AL square rho G, which becomes 2 pi under root L by 3G. So if you see 2 pi by N under root L by G is what they have given. So this means the expression for N is root 3, which we will approximately take as 1.73. So this was an integer type question. So 1.73 approx we can take as this. I hope this is clear to all of you. Okay, let's see the solution of question number 10. So you can see that there are 5 Carnot engines in succession, and they have said that each one has efficiency eta. Every engine has efficiency eta and same number of cycles per unit time. They are operating between 6 reservoirs in between. The amount of heat released by one is completely absorbed by next engine. They have mentioned like this, which you can see in the diagram also, flow diagram they have shown. Now Q naught is the heat absorbed by first one, work W is the amount of total work done by all the engines. These two terms they have mentioned. Q naught is the heat which is absorbed by first reservoir, and W is the total work done by all of them. So they are saying the net efficiency is W by Q naught, which is 211 by 243. So what is the value of eta? Net efficiency is 211 by 243. So they are asking the efficiency of each engine, eta. So let's proceed with solving this question and what we can write. So first of all, what we can say from here is each one's efficiency is eta. So efficiency is work done by heat supplied. So we can say for first one, work done is W1 and heat supplied is Q0. Now this same efficiency is of second engine also. So for second engine it is W2 by Q1. For third one W3 by Q2. Fourth one W4 by Q3, and the last one W5 by Q4. Clear? So from here, now since total work is W, so let's try to write each work done in terms of Q0. Can we write it? Let's see. W1 can be written as eta Q0. We already got it in terms of Q0. What about W2? W2 is eta times Q1. Now can we write Q1 from here? Let's check what we can say. Since Q0 is equals to Q1 plus W1, so I can write from here Q1 is nothing but Q0 minus W1. Similarly, if you see Q2 is Q1 minus W2. In this way we can proceed. So here if I write eta Q1, so Q1 is Q0 minus W1, and what is W1? W1 is eta Q0. So when I substitute W1 is eta Q0, so from here we can see W2 can be taken as eta into 1 minus eta Q0. So I got W2 also in terms of Q0, I got W1 also in terms of Q0. Similarly, when we write W3, it is Q2 into eta. So if it is Q2 into eta, again Q2 can be written as Q1 minus W2. So Q1 we already have here. So just this step, Q1 we got Q0 minus W1, which was Q0 into 1 minus eta, and minus W2 is eta Q1. So eta Q1, which we got eta into 1 minus eta Q0. So if you take eta Q0 outside, 1 minus eta common, so again in bracket you will get 1 minus eta. So this becomes how much? 1 minus eta square. So proceeding in this way, we can say W4 will become eta Q0 1 minus eta cube, and finally W5 will become eta Q0 1 minus eta power 4. So each one we got in terms of eta and Q0. Now comes the real part where we have to write the total work done. So when we write the total work done, we have to add all of these. So when I write W, which is the sum of all, so you can see what will come common is eta and Q0. And if you see in W1 we just had 1 plus W2 we have 1 minus eta, and in the last term we have 1 minus eta power 4. So it is nothing but a finite geometric series where the common ratio is 1 minus eta and there are 5 terms. So we know what is the sum of a finite GP. It is A into 1 minus R to the power n by 1 minus r. So writing in that way, we can write eta q naught, first term is 1 minus common ratio is 1 minus eta. How many terms I just said? 5 divided by 1 minus r, like this. Now you can see this becomes 1 1 cancels, eta and eta also cancels. So we are getting how much? Q naught 1 minus eta power 5. This is the value of W. So now coming to the final part, net efficiency is W by Q naught. So when we divide W by Q naught, how much we are getting? We are getting 1 minus eta power 5. This value they have mentioned as 211 by 243. So from here 1 minus eta power 5 will become 1 minus 211 by 243, which is nothing but 32 by 243. But here power is 5. Can we write this as 2 by 3 to the power 5? So from here 1 minus eta becomes 2 by 3. That means eta will become 1 by 3, which is approximately 0.33. So correct answer for this question should be 0.33. I hope this is clear to all of you. We'll proceed with the next question. Okay, let's see question number 11. So in this figure we have an insulated chamber and there is a piston P2 which can move freely such that the pressure of the compartment S2 is always constant and equals to atmospheric pressure, right? So some conclusions we can draw from here, that in this S2 the process will be isobaric. Now in S1 this P1 is fixed partition, so its volume cannot change. That means S1 compartment will have the gas undergoing isochoric process. So isochoric and isobaric. Now this partition they have given the thermal conductivity P1, which is a fixed partition. Thermal conductivity is given and they are saying that if the temperature difference initially between S1 and S2 was delta T naught, then in what time the temperature difference will become delta T naught by 2. Whenever we have such questions, we always proceed with a general instant and we gradually see what change is occurring. Okay, so what we have to do here is we can take this partition P1 whose thickness is X, and left side let's take this temperature as T1 and this side temperature at T2. So I am talking of a general time instant T equals to T, and I assume that dq amount of heat flows from this side, causing temperature change, a small temperature change, dt1 in left and dt2 in right side. So this heat flows, right? Now what all things we can say from here? First of all, we can write dq. Now this has flown from S1 to S2, so obviously its temperature will decrease. When it is isochoric process and you are releasing heat, so obviously temperature will decrease. So dq for left compartment I can write minus NCV dt1. Now they have given 1 mole, both are containing 1 mole of monoatomic gas. So moles are 1, CV is 3R by 2, so minus 3R dt1 by 2. and dq, if I use it for second compartment S2, this heat is entering, so it will increase the temperature. So we will write positive N Cp dT2. Now it is also monoatomic gas, so 5R dT2 by dt. This is what we can write. Now if you see across P1, when we consider conduction, if you see across P1, the conduction, we know the thermal current dq by dt can be written as K, the cross sectional area, I think they have mentioned, yes, A. This side T1, this side T2, we have assumed T1 is higher, so T1 minus T2 by watt length X. Now here we have to find the temperature difference between S1 and S2 as a function of time. So we have to remove dq. How we can do that? We have to bring this side also as a function of T1 and T2, T1 minus T2. So how to do that? See, from this equation we can find dt1 and write it as minus 2 by 3 R dq, and from here dt2 I can write as, I'm sorry, here I think I have put one extra value, 5 dt2 by 2. So here dt2 will become 2 dq by 5R. Got it? So if I subtract these two, dt1 minus dt2, what will I get? dt1 minus dt2 will become minus 2 by 3 minus 2 by 5 into dq by R. So it will become 5 plus 3, 8, 2s are 16, minus 16 dq by 15R. So what now we can do is, we can substitute the value of dq as minus 15R by 16 d times T1 minus T2. So if I put it in this equation over here, so we can say dq by dt, which is minus 15R by 16 d T1 minus T2 by dt will become equals to Ka T1 minus T2 by X. Got it? So now let's call T1 minus T2 as delta T. So d of delta T by dt, take the remaining terms one side, minus 16 Ka by 15 R X delta T. Now if you see this differential form, can you see it is a decay type reaction. So it is a decay reaction. So decay rate case, just like radioactive decay, and they have said the temperature difference falls or becomes delta T naught to delta T naught by 2, means it becomes half. So the time taken, they are asking the time taken, so that time will nothing be but it will become T half. Understood? And what is the formula for T half? It is natural log 2 upon lambda. So just substitute what we have in place of lambda and we are ready with our answer. So ln2 value is 0.7 they have taken, and lambda value we can see is 16 into 15, and rest we have Rx by Ka. So Rx by Ka is as it is, so they are asking the value of N. (15 into 0.7) 10.5 and divided by 16. So this is approximately 16 6 are 96. Okay, and then 0.66. So N is around 0.66. I hope it is clear to all of you. Okay, let's discuss question number 12. We have a hollow right circular cone whose base radius capital R, height is h, and tip is at origin, and it is rotating about the z-axis with angular speed omega. Now they are saying that the total charge q is distributed over its curved surface. The magnitude of magnetic field at a point 0, 0, z, where z is very large compared to capital R and h, is given. Then what is the value of n? Well, for this question, what we can simply do is, you can see that the value of z, they have mentioned already in the question that z is very large. The point where you have to find the field, that z is very, very large compared to h and r both. So it is a far away point. So we can take the hollow cone can be treated as a magnetic dipole, which will be equivalent to a bar magnet. So they are asking its magnetic field, so whose B at axial point, which is at z distance, will be just like that of a short bar magnet. At its axial position. That's it. So we can say B will become, for a short magnet we know, 2 km by z cube, where k value is mu naught by 4 pi. So 2 mu naught m is the magnetic moment by 4 pi z cube. This is the value of P. Now we have to find m. How to find m? We can find by using the gyromagnetic ratio. We know gyromagnetic ratio, m by angular momentum about the axis of rotation, is total charge by 2 times total mass. Angular momentum is I axis omega. So from here m will be what? The total charge is given as capital Q, omega by 2m. Now angular momentum is I omega. Moment of inertia is for a hollow cone about the axis shown is mr square by 2. So m r square by 2. Cancels. So we have got q omega r square by 4. So just now we substitute. So B value becomes 2 by 4 will become 1 by 2. So mu naught by 2 pi z cube is what we are having, and apart from this we are getting m whose value is q omega r square by 4. So if you see the terms, they are saying, if we express it in proper way, what we are getting, mu naught by 4 pi, we have taken it. Then we have q also, omega r square, everything is obtained. Below we have z cube also. Extra what is remaining is 1 by 2. So they are asking this value of n. What is the value of n? So simply we can say that this 1 by 2 is n. So n is 1 by 2, which is 0.5. So the correct answer for this question will be 0.5. I hope this is clear to all of you. Okay, so let's discuss question number 13, in which we have been given a match the column type question with 4 arrangements. We have tubes in the shape of semicircle or straight tubes, and we have these combinations given in P, Q, R and S. They are saying that there is a source which is emitting waves of wavelength lambda is equals to 0.29 meter in each case, and at the other end, other opening, you can see there is a detector which will be detecting what? It will be detecting the maximum amplitude. Maximum amplitude means it is case of constructive interference. So simply we have constructive interference, and they are asking what will be the least value of small n in each case for constructive interference to occur, or the detector has to detect a maximum in amplitude, right? So how to solve such questions? This question, let me tell you before starting that this question is very easy. Only thing is that you have to take suitable approximations to get the calculations fast. And they have given one approximation to be taken, cos 15 degree they are taking as 0.97. Okay, so let's start and see which option will come for this. First of all, when I said the path difference delta x, this will be n lambda for constructive interference. Now you can see the path travelled by the waves from S to D, they all will be in multiples of L only, because this length is L, this is pi r, and r radius is also related to L. So in short, all the paths travelled in all the 4 cases P, Q, R, S, they will be multiples of L, right? Now if they are in multiples of L, so delta x will also become multiple of L. Now if delta x is a multiple of L and we are asked to take the least value of L, obviously non-zero value, that means we have to take the least value of n. So n should be taken as 1 for the least value of L. Okay, so we have to simply equate path difference to lambda. So let's start. First one is for P, delta x will be what? One is semicircle, for which we can write pi r is the length travelled, and straight length from S to D is L. So pi r minus L. Now this value is to be equated with lambda. Now what is r? You can see the radius is 0.5 L. So radius being 0.5 L. So from here we have L equals to lambda by, now you see, 0.5 into pi, 0.5 into pi, pi by 2 minus L, pi is 3.14, right? So 3.14 pi 2 will become 1.57 and minus 1. So this becomes, lambda is given as 0.29 and 1.57 minus 1, 0.57. Now I am talking about the approximation. We know 29 twos are 58. So 0.29 by 0.57 will be approximately 1 by 2. So 1 by 2, that is the value of L, can be approximately taken as 0.5 meter. So 0.5 meter closest one, do we have any match? Let's see. In all the four, P matches with 3. So if P matches with 3, which all are possible options? Which are not possible? A is not possible and B is also not possible. So we are left with C and D, right? Now let's see the next one, which we have over here is for Q. Now if we talk about Q, in this case you have the part difference to be taken. If you see delta X, this length will be how much? 0.5 L, 0.5 L plus L. So we have 0.5 plus 0.5 L plus L. So we have 2L minus this length is how much? L. So part difference is simply L. And L is to be equated to lambda. Lambda is how much? 0.29 meter. So delta X is 0.29 meter. So for the second one, if you see Q, 0.29 is matching with 4. So P is 3 and Q is 4. P is 3, Q is 4. This is present in both C and D. So we have to check for the next one also. If you see the next one, R. Now in this case, we have this length as L. Now if you see from here, this being L, this being L, so this length will become root 2L. So if this length is root 2L, so radius will become L by root 2. Got it? This is the diameter. Diameter is root 2L. So radius will become how much? Root 2L by 2. That is L by root 2. So this is semicircle. Semicircle length is pi r. So how we can write the part difference over here? So delta X. First we have L plus semicircle. L plus pi r. And from here we have to subtract direct length L. So L plus pi r minus L. So L cancels. And this is to be equated with lambda. Now from here pi and r. R is L by root 2. So pi L by root 2 is lambda. So from here L will become root 2 into 0.29 lambda value by pi. Now here also, if I want to go by the calculation, what I can do is, just see here, I am using this calculation here, root 2 for the third case, for R, when we have root 2 into 0.29 divided by pi. What approximations we can take? See, root 2 I can use 1.4, 0.29 approximately you can take as 0.3, pi approximately you can take as 3.143. So from here you can see this will come how much? 0.3 into 10. So 1.4 by 10, this will become 0.14. So do we have any option which is very close to 0.14? Yes. In R we can see 0.14, 0.13. This one seems to match. So R is 5. So P3, Q4, R5. So which one is the correct option? So you need not check S. We can do that. We can find S also, no problem. We can find this length minus this length, again equate and solve. But we directly got our answer from P, Q and R. Clear? Now let's move on to our next question. Question number 14. Now this question also is a very simple one. I would say that if you get questions like this is just like hitting a jackpot, because these are some concept based things to remember, informative questions, so which you can directly look and see which option will be correct. No calculations required. But since we are going through detailed explanation, so I will be explaining the terms so that you understand what is being occurring in this particular cases or these particular cases. So in list 1, first one you can see colorful sky in North Polar region, aurora borealis. Now what is the mechanism for this? Our sun, it keeps on shooting charged particles in space, right? And this is in the form of solar winds. Now these solar winds, they try to enter into the atmosphere of Earth also. But there is a magnetic shielding around the Earth's atmosphere which prevents these solar particles or solar charged particles to enter the atmosphere, which can be very harmful. But this magnetic shielding is very less near the poles, near the North Pole and near the South Poles. So there these solar charged particles, they manage to enter through the atmosphere, and when they enter, what they do, they strike the gases, especially oxygen and nitrogen, their atoms, they go and strike them, and these atoms, they get excited. Now when they get excited, after that they will try to stabilize themselves. So when they try to stabilize themselves, what they will do, they will simply release energy, and these released energies will be observed in form of lights. Now I said that this occurs in both the regions, North Pole as well as South Pole. In North Pole, when we see those lights, we call them as aurora borealis, and when we see this colorful sky in South Pole region, we call them as aurora australis. So aurora borealis for North Pole region and aurora australis for South Pole region. So I think this explanation is sufficient. So A, B, C and D, which one will match? So for that, first we see P. P matches with colorful sky, emission of radiation from oxygen and nitrogen atoms excited by solar charged particles. So P will match with 5. So that means which all are not correct? C is not correct, B is not correct. Now let's see the next one, partially polarized sunlight. Partially polarized sunlight, okay, suppose I have a confusion, I will explain that later. As a student, suppose I am solving, I don't know partially polarized sunlight, what will happen. But rainbow, I know rainbow, we see multiple colors, that is because of dispersion of light, okay, caused by the suspended water particles after rain. So when sunlight falls and enters these suspended water particles, it undergoes dispersion and total internal reflection, based on which what happens, we are able to see primary and secondary rainbows. But total internal reflection is not the main reason, it is mainly due to dispersion and reflection. Dispersion is first of all the main reason for seeing rainbow, otherwise just for TIR you won't be seeing rainbows. So rainbow, the correct option matching will be 1. So P5R1, P5R1, we can see that P5R1, okay, it is in A and D both, no problem. Next, very simple, we know dark and bright fringes. So dark and bright fringes we study in interference or in diffraction. Have they given interference anywhere? No. Have they given diffraction? Yes. So directly dark and bright fringes will match with diffraction. So S will be 3. So S is 3, which one will be the correct option? A. So A is the correct option. And let me quickly explain this also, the part Q, partially polarized sunlight. So when sunlight, it is unpolarized, it has got electric and magnetic field vibrations along all directions in space. So when it will enter our atmosphere, it will be scattered not completely but partially by the molecules in the atmosphere, and due to this scattering only we say that the sunlight is partially polarized. So what is the reason Q partially polarized is because of scattering. So R matches with, partially polarized. Q matches with 4. So Q matches with 4. So option A will be the correct one. I hope this is also clear to all of you. Let's move on to the next question. Okay, question number 15. Now this question from IIT JEE Advanced 2026 is my favorite. Why? Because when I say that there are questions put in by the JEE setters which are just like hitting the jackpot for students. Why? Because match the column type questions, some questions like this, especially these one, you don't have to do any calculation again. Just you can see or rule out which are the improbable or impossible options. So you can easily get which one is correct. So what we can see over here, in all these you can see that there are circular loops or sectors which are rotating in transverse magnetic field. The magnetic field region is uniform and transverse. Transverse means perpendicular to the plane of the loops, right? Now, whenever such rotation happens and with omega, constant omega, and till the flux will change. Why flux will change? Because as the loop will enter or come out, partial area of the loop is inside the field, then flux will be changing. When the complete area of the loop is inside the field, there will be no change in flux, right? So what we can say that at any instant, if a sector of angle theta is inside the field, if at any instant a sector is inside the field, so we can say the flux will be what? B into A. Field is perpendicular to the plane of the loop, so directly B into A. A is the area lying inside. Now we know area of a sector is, if the radius is R, so theta R square by 2. So what happens over here, since it is rotating with constant speed, induced EMF magnitude if you take, so you will take mod of d phi by dt. So it will become b r square by 2 d theta by dt. Now d theta by dt is what? Omega. And omega is constant, so induced EMF will be constant in magnitude. So the induced current I will be induced EMF by the resistance of the loop. Now total resistance of the loop is fixed, so this value is also constant. So this one is during flux change. So during the flux change, in such cases you can easily remember. So what all I wrote here, you should know this thing, and when you know this thing, that the magnitude of EMF should remain constant during the flux change. There will be positive and negative half cycles, that is for sure. If the direction, once flux is increasing, once flux is decreasing, so there will be change in the sign of EMF and change in direction of the current also. But during a particular type of flux change, whether only flux is increasing or whether only flux is decreasing, at that time, in such cases, the EMF will remain constant whenever we have circular sectors or loops in uniform magnetic field and transverse magnetic field and rotating with constant omega. So once we know this, so I can simply rule out the option which is not possible. Which one is not possible? Fifth one, you can see here current is changing, increasing or decreasing. Not possible. It can either be 0 or constant, non-zero constant. It cannot be increasing or decreasing like this. So fifth one is not possible. Now you see why I said this is hitting a jackpot. You can see in option A, you can see 5 is there. Option B also there is a 5. In option C there is no 5. In option D you can see there is a 5. So which one is not possible? In any case 5 is not possible. So the correct choice will be option C. So option C is the correct one. So you saw, you directly got the answer, option C, P3Q2 R1 S4. Now I will explain you one more thing, which is the case of S. Now when you see this S, you have this sector entering in the field and this sector exiting. So in one of the sectors, half sector, you can see the field, the flux is increasing and here the flux is decreasing. So the directions of EMF induced in them will be equal and opposite. So what will happen? They will cancel each other. So in this case, the flux will always remain zero. Net flux will be always zero, that is constant. Net flux is always zero and constant. So induced EMF, which is the rate of change of flux, it will be zero. So it will be always zero. So S should match with which one? 4. So you got the question solved very easily. I hope this is clear to all of you. Okay. Okay, so we come to the final question of this paper. Question number 16, again match the column, in which we have to find moment of inertia. This again is a very simple question because it is just based on a combination of rods and we have to find the moment of inertia. So you all know the results for moment of inertia due to a rod about different axes. So we can quickly solve it. Let's see. First we have for P. Now both the rods, this axis OO dash is the end axis. For both the rods, it is end axis. And for each one, you can see the axis makes 45 degree with the rods. So when we have the axis inclined at theta angle with the length of the rod, then we replace L by L sin theta. That's it. Now since for both the rods it is end axis, so you will use M L sin theta is 45 ml square by 3, end axis formula. Now how many rods are there? 2 rods. So here each one is of mass m and length L. They have made the question very simple from here. So this we can write. It becomes sin square 45 is 1 by 2, 2 cancels. You get ml square upon 3. So P matches with ml square by 3. That means P5. So P5, which one is not possible, hence B option is incorrect. Now let's move on to the next one, which is Q. Now in Q we have a triangular frame formed by 3 rods. For 2 you can see it is end axis making 60 degree. Now this rod, it is parallel to the axis. When a rod is parallel to the axis, we know the rod is taken of negligible length. We simply take for such rods the moment of inertia as m into distance square, m into this length. Now if this length is L, this length x, this angle we know is 60 degree. So what will be the value of x? X will be L sin 60. L sin 60 means L root 3 by 2. So what we can simply write here for Q, I O O dash. 2 rods, it is end axis making 60 degree just like the previous one. 2 m, L will be replaced by L sin 60 whole squared upon 3 for 2 rods. Now one rod which is parallel to the axis, you will simply write mx square. And what is x? X is L root 3 by 2. So let's put substitute the values. First of all, you can see sin 60 is root 3 by 2. So when you square it, it will become 3 by 4. 3 cancels. So ml square 4 by 2 will become 2. Now from here mx square, x square will become 3 ml square by 4. So if I take the LCM as 4, 2 plus 3, 5 ml square by 4. So we can see for Q, which one is matching 5 ml square by 4. For Q we have 1. So P5 Q1. So which one is the correct choice? Obviously A. So rest of the cases are wrong. Still, let's solve the remaining ones also. Just to cross check. For R, it is a square frame, and for each rod, end axis, the axis is end axis and making 45 degree with each rod. Because you can see total angle 90, so each rod will make 45 degree. So there are 4 rods. So IOO dash is simply 4 times M L sin 45 whole squared upon 3. So basically it is nothing but double of this. Clear? So this will become 2 ml square by 3. So R matches 2 ml square by 3 means R is 4. So you can see R is 4. And the last one also, if you see the last one, which is S, here we have only 2 rods, end axis making 30 degree each. So 2 times ml sin 30 whole squared upon 3. Now sin 30 is 1 by 2, so 1 by 4, 1 by 2 in 3, 6. So it will become ml square by 6. So we have ml square by 6, S matches with. So yes, option A is the correct one. I hope this question is clear to you, and here we end this paper. So if you like the video, do share with your friends, do subscribe, okay, and stay tuned for further videos. And also in the next video we will be discussing the complete JEE Advanced 2026 paper 2 of physics. Thank you.